one, start.
Okay, for our project, we analyzed predictors of academic performance using regression analysis. We built the linear model and two logistic models. Next slide. Ability to understand key factors. It's important for educators, for parents, and teachers alike. And what we wanted to do was figure out what predictors are the most significant and which predictors predict the best odds of success for a student. Next slide. So first section that we're going to go over is just some summary stats and box plots of the data. Next slide. So the data summary. First summary I want to show you is a histogram of the three, which is our dependent variable. That's the final grade, and you can see there's a negative skew to the data because there's 5 students that apparently didn't show up for the final or didn't take the final, so they got zeros, and that's causing a negative skew in the data. It's not bad, but in order for the linear regression to make sense, this would likely require a natural log transformation. Next slide. It's the data summary. This is a box plot of dedication, and I'm showing so that's your final grade by study time on the left, and then by failures on the right. I didn't include for the logistic regression. I didn't include failures because it's kind of obvious if you failed in the past, you're probably going to fail in the future. But you can see study time. There's a pretty strong linear or positive relationship between study time and final grade. And these are broken out into categories. So 1 is just showing less than 2 hours. 2 is showing between 2 to 5 hours. 3 is showing 5 to 10 hours, and then 4 would be greater than 10 hours. And for my model, I did break down these dummies. I'll go over that when I talk about my model. Next slide. So the next one is family. We found this to be a pretty significant predictor as well. So if the parents are cohabitating or not, you don't see a big difference in these box plots here if they're living together or apart. But when you look at the distribution of final grades by guardian, you do see if the student comes from a household that is other than being raised by the father or mother, you do see a decrease in the final grade. Next slide. And now we have a distribution by family relationship. So we're trying to use the strength of the family relationship, and this is survey information. So kids ranked if they had a strong relationship with their family at 5, a weak relationship at 1. You do see somewhat of a positive relationship with grades as the strength of the family relationship increases. When I did this, I didn't look at it. I didn't create dummies for each one of them. I lumped 4 and 5 together and said, okay, that's a strong family relationship. Otherwise, 0. 3 was an average, and then 1 and 2 would be poor. And then I could run a regression on 3 average student family relationship and strong relationship, and then my results would be a weak family relationship. Uh, Next slide. So more on family here, we're showing this is education, which when I go over the research literature review, you'll see that this does have an impact. Um, so I have mother's education level on the left and father's on the right. The only variable that really is 4, which is saying that the parent actually has a college education. Interestingly, you do see uneducated relationships seem to be pretty strong with strong, high final. The final grades are really high, even though their parents have 0 education, and then it seems to go way down and it increases as you reach. Okay, next slide. Social life. We speculated that there would be some kind of maybe social life, but you're not seeing a very strong relationship here. This goes from 1 to 4, from very low social life to very high, and then you see the grades. Not a very strong relationship. Romantic relationship on the right is showing if they're romantically involved with a partner or not. You see a little bit more variation in the quartiles for yes, and a little bit lower grade, which I guess would make sense because they're spending more time with a girlfriend or boyfriend than studying. Next slide. So some other noteworthy ones I wanted to show internet access because you do see a big jump in final grades for students who have home internet access. This could be that could be interesting for future studies. Maybe you could look at, because I would also assume that this has something to do with income. Maybe you could say like people with no have very low income, so maybe you could use this as like a instrument variable for income if you wanted. But you do see a lot higher grades for students with internet access, easier access to information. And then you also noticed, I was surprised too by this, by the big gap in rural versus urban students' final grades. So if you come from an urban background, you do see a pretty significant jump in final grades. Next slide. Assumption. This was actually one of the data set was entitled this because they were trying to initially study what's the effect on alcohol on grades with alcohol consumption, and you do see a downward trend as alcohol consumption gets higher in both the workday and weekend consumption. Again, I grouped these, so I said if it was 4 or 5 on the weekday, then that would be high. It's applied the same logic as I did with family relationship for both of these, so I didn't have an individual variable for each. Um, Next slide. Literature review, a 2009 study examined the links. Now, this was mainly like how alcohol affects sleep, and then the sleep in turn affects GPA. And they didn't have a very large data set in the survey, but they did show among these college students is related to the sleep wake patterns that support connection between alcohol use and lower grades. There's another study in 2009 that this one also had a pretty low, I think it was less than 200 observations, and they showed no actual direct correlation between alcohol use and academic performance. Next slide. Family structure references in 2015. Now, pretty much every one of these agree that if you come from a broken family, see lower scores. The first one uh, was focused on student attendance and how family structure affected attendance, which in turn affected uh, grade scores. And this was middle grade, so I guess it's a little different in college. And it was just mathematics standardized tests, but they did show that these children that came from families where they did not live with biological parents showed a negative relationship to overall grades on those standardized tests. A 2003 study showed a positive correlation. And this is right in line with with some of my results. Is that like a student comes from a family with a parent that's a teacher or has an educational background, you do see a positive relationship with that in grades. So this study confirms what I was able to reconfirm here. Another study, 2009, concludes that students from a single family homes will perform lower than two parent family counterparts. Um, and then finally, the last study is showing that students coming from traditional two parent homes, comprised of both biological parents, outperformed students who did not have the common factor. I'll turn it over now.
All right, I did the linear regression section for this project. The purpose of my model was to answer the question, which attributes predict academic performance in math or in Portuguese class, and to what extent did they actually make this prediction. My dependent variable was a G3 numeric final grade between 0 and 20. And for my, I created numerous dummy variables to transform characters. And throughout my dummy variables, I stuck to some standards. If there was an other section, then other was set to be 0, set to be all 0. And for binary variables, yes was always 1, no was always 0. And then I used a stepwise comparison to get my final model. So my sample rate was 70, and I used a seed of I used two different seeds for both my math and my Portuguese sections because I split my data up into only math and only Portuguese, so I could more concretely measure both. So for my final model for math, you can see I only got a F value of 9.87, which isn't great, but it's not so terrible that we can say that that this model was completely useless. Also notable is that all my p-values, as you can see, all my p-values are below 0.5, and I had no VIF values greater than 10, meaning that I had no multi-collinearity. Um, So for my training versus testing, as you can see, my testing values for MSE and RMSE were greater than my training values, and because we are looking for we're looking for as low as possible for both those values. This does mean that my training was worse than my testing when fitted to this model, which makes sense because this model was built based around the training set. As far as my R squared values go, both R squared values are within zero point zero 0.03 of each other, meaning that this model didn't have any overfitting or anything, and it was a good model in that sense. So what does my final model for math essentially uh, that for says that basically for every point unit increase in each of my uh, dependent variables, I have the the parameter estimate percentage increase or decrease in my G3. This is percentage increase and decrease because I am using a log transformation on G3. Um, For my final model for Portuguese, as you can see, the F value is much greater compared to my final model for math. And once again, my p-values are all below 0.05, and I had no VIF values above 10, meaning that there was, once again, no multicollinearity. And for my training versus testing for my Portuguese final model, this time I actually got my testing set to be lower than my training set, so that meant that for the given model, the testing set was a better fit, um, which was cool to see. Another thing to note is once again, the uh, R squared values for both testing and training are very close, within zero point zero 0.03, meaning that it was once again a good model in that sense. So what does this model say? Once again, this is all set to log G3, meaning that each of the dependent parameter estimates are percentage increase and decreases in the original dependent variable, which was G3. What's most notable is that my, Portuguese had a much higher F value than math, meaning that it's much easier to say, meaning that Portuguese was much more dependent on the variables that we had access to than math was, which kind of makes sense because math can be thought of as a more logical, what's called a more logical subject, while you have Portuguese, which is a not it's not as logical, and a lot more emotion and feeling plays into it, so that your emotional status or your situational status might affect your grade even more. All right, and now passing it on to sorry, I had the slide here. Yeah, as you can see the comparison, and now passing it on to Josh.
Yeah, I ran a logistic regression model to predict what top percentile, what predictors for top percentile academic performance. So next slide. So the purpose of my model is answer which attributes predict top academic performance and to what extent. Of the G3 of the final grades. Any grade that was like in the 16 plus range tended to be in the 90th percentile. So I said, all right, well, I need a dichotomous dependent variable. So I take the top percentile, and that's equal to 1. And any final grade that's less than 16 is equal to 0. Um, my explanatory variable selection was kind of more theoretical first, based off of the literature reviews. So I had the a lot of the family indicators in there, alcohol consumption, but then I included several of the other ones as well, just for good measures. um, going over my dummy variable transformations when I was going over the histograms, using high, average, and low instead of all 5 variables. I compare stepwise backward forward selection to identify significance to kind of narrow down variables. And I divided my data in the training sets based off the seed below and a sample rate of 7.7. Next slide. I stepwise forward backward, they all had the same basically the same as the SC, but the likelihood ratio was a little bit higher and backwards. So I just went with backward, but all the variables were the same anyway. So yes, next slide. My logistic regression model is showing, saying beta 1, none of the coefficients are statistically significant. Alternative would be that at least one of them is. Top performer, the log of top performer. The big predictors were if your mother has a higher education degree, and that's a positive effect. The college, your mother having a college education will increase your odds of success by about 113%. The next one, research about coming from a family with an academic background. So if your dad was a teacher, you do see a positive effect. Your odds of success increased by 182%. One is pretty obvious, I suppose. If you study 10 hours plus per week, you will see rates of odds of success by the most, actually, by 198%, according to this model. And then there's a negative one for additional education support. And this is outside educational aid. So my understanding, looking at the data, this is if the student's receiving some kind of financial aid or outside support. Maybe these types of students just don't perform as well as what the model's telling me. So you decrease your odds of success by 93.4% relative to those who don't have that outside support. That could definitely warrant further study as to why that is. The last one, strong family relationship, is a positive. It'll increase your odds of success by 152%. And then other just noteworthy variables is I did have other guardian and weekend heavy drinker as significant, but they were not at 5 percentile, the p-value of 5. It was like around 10. I would probably include them theoretical reasons, but just for since they weren't statistically significant, I have them out of the model right now. Next slide. This is just showing some model diagnostics. I had a few outliers, but my DF betas is only showing one real influential point when I take 2 divided by the square root of my n. Just a quick view and the sum of the outliers and influential points. There's not too many. Next slide. So this is my confusion matrix, and it's showing the model performance. And if you look at the training set, sorry, the test set was 313 of the 1,040 observations. You can see a pretty strong true negative rate, and then there's a little bit accuracy isn't the great, or precision isn't the greatest. Accuracy is, and they're actually, these are pretty good measures. If you look at just the confusion matrix alone, shows that yeah, we did have a few false negatives there, or sorry, a few predictions of 0 where the person ended up being a top performer. But overall, the model's pretty good. It's adequate, statistically significant, and predicts with a pretty high degree of accuracy. So next, I guess I'll turn it over.
So my part of the project was the second part of the logistic regression. So mine I did in part to compare with Josh's. So next slide. So in terms of the distribution of the final grades, it's obviously slightly redundant in terms of what Josh displayed earlier, but my idea was that the histogram doesn't show that much of a skewness, but it is something in terms of the linear regression that we could use transformation. But in terms of that, the final grades didn't seem that it needed a lot of adjustment. Next slide. I decided to use I just wanted to get a look at the distribution of the age in terms of the final grade. So the age, it seemed like it was a lot spread out for the younger ages of the students. But as the students got older, it's kind of interesting in terms of this itself being that the age range from 15 to 22. So you can't really, decide if this is, high school or if it's college. But in terms of that, you would assume it's a little bit of both in depth. And in terms of that, the median values are around the same for most, but the ranges come from the ages in the students in the teenage range, and that gives more of the variability in terms of the differing values in terms of all the information provided. Next slide. Also wanted to show what the study times and the failures look like. So the failure is obvious if you're not time, you're obviously allowing yourself for more degrees of failure. And then if you're putting more time into studying, I mean, we would all say that studying will be something that would help us in terms of testing. And this showed that distribution as well in terms of how the median values for the students who studied between 1 and 4 hours, how those ranged, and actually the top score in terms of the range from 0 to 20, testing at a 20 was from the student from a student who studied within 4 hours. Next slide. My logistic regression analysis, I also used the forward, backward, and stepwise, and my ranges were the same in terms of everything that the the selection spit out in terms of the data. Mine was slightly higher than Josh's, so his model actually, in terms of how it's depicted, it was a little bit better than mine because I actually used different variables. And in terms of those independent variables, I actually ranges for the mom with the high education, the dad with high education, the size of the family, mom having a job or not, this, and then determine that on top of the gender, the status of the parent, the adult figure, whether that was mother or the father, the support from the school that a student would get, the family support that they would get, if they paid for the schooling or not, if they were involved in activities, access to the internet, or if they were or were not in a romantic relationship. Slide. The breakdown and the frequency of performance, since I used the sample size that was slightly higher than Josh, so I used the 88% testing, excuse me, 85% testing, and that showed the discrepancy in the data, but everything seemed significant, and obviously it knocked out a number of the independent variables that I had originally used. The ones obviously that the remained in the distribution were the factors that of the gender, the mom who had higher education, the support of the school, and if the student had paid for services or not. So that was obviously significant information, and those were the significant variables within the data itself. Next slide. In terms of my regression, like I said, I was more determining of that academic, what was a big determining factor in the academic success of a student and what had the most impact. In terms of the variable, like as I mentioned, I used for the student testing scores, it was seemingly the test that was graded at a B average or better. So out of that would have been a 16 and above out of the 20 for the testing. Those were variables to include what I felt like those big determining factors in what determines the success of a student or not. And I wanted to portray the factors that I felt mostly kind of related to how I looked at the school, how I looked at student performance and my own personal performance. And for that seed, I used 987 and 321, and then, as I mentioned, the sample rate of 85%. My final model, it was a little different in terms of the variables I used. So being that I did use those three model selections, it was still a little bit different in terms of what the model ultimately displayed. See the gender, the education for the mother, the support of the school, and being paid for the school were the factors that were the most significant for the data. And then that depiction shows below.
Overall, we did decide that Josh's was the best model, and going forward, some ideas we each had was getting a bigger data set, obviously, but I specifically wanted to find more classes along lines of like the math and Portuguese split, such as having a science class be offset with an art class and see if I can get similar representations on both sides, as in the art class being more heavily influenced by the variables, these same variables when compared to the science class. And for Josh, Josh?
I guess just to add one last comment,
Mm.
I think I agree with the getting more variables, more attributes to try to other way, maybe household income or poverty level stats or something to see how, like socioeconomic indicators could predict academic performance. Maybe get more demographic variables, but a route for future studies. I think I got more questions from building the model than I answered, but that's about what all I would have to say. Anything else?
I think it was another big thing that would you can always determine significance on is the gender of the student. So that's you can obviously do further models. I think we had a very good sample size, being that it was over like Josh said, it was over 1,000 samples. So it was a good depiction of the model. But if we want to get like kind of equal the gender, and then as well like more factors of what's going on in their home, and kind of being a little more specific in terms of the ability to use that, as we said, the internet, and actually how the education for the parents was described, and then also the guardians involved, because we still had separate guardians, whether it was the mother or father, as opposed to it was a two-parent household included.
Yeah, and just to tagging along on that, I think when I saw that parents with no education, how it was almost in line with students who had parents with like college degrees. I guess that would be interesting to look into why these students performing so well with their parents come from no education. Maybe it's coming from uh, no educational background. Maybe they had something to prove, but I think that could be pretty cool to look into.
And then piggybacking off that as well, then as deeper you dive, you also dive into the race of the student, because that's always something that people look at as a factor for determining a student's success, whether they're black, white, or from another country, or citizenship. There's a lot of factors that you can dive into to see exactly what determines the success of a student. Because I know of experience of a lot of students who have had, where maybe they were the first to graduate in their family, or factors of that, or students who came from, as Josh stated before, came from more of a wealthy household and race.
All right, well, we're out of time, but thank you for watching our presentation. My name is Aditya.
My name is Suleiman Muhammad.
I'm Joshua.
All right, we'll see you next time.